Very good morning, children. Welcome to SVS e-learning class. This is your physics subject teacher Firoz Khan from Sri Vidya Sai Central High School. Okay, children, we have completed the two chapters from the chemistry. That is the first we have studied about chemical equations, and the second we studied acid, bases, and salts. Okay, and I hope you all well understood about those two chapters. Okay, and still if you have any doubt, you can ask me from that lessons. Okay, children, now we are going to study the third chapter from our the chemistry. That is in your round physical science. That is the sixth lesson. That is atomic structure. Atomic structure. Okay, children, you have some of the knowledge related to the atomic structure in the ninth class. Already we know that all the matter is made up of tiny particles are called molecules, and each molecule contains atoms, and each atom has subatomic particles. We commonly called as a pen. As all know that means proton, electron, and neutron. Yes, proton, electron, and neutron. And a proton has a positive charge, electron has we know that is a negative charge, and neutron there is no charge. Okay, yes, and this one we can call as a positive and electrical neutral, and this is we call as a electrically neutral. Electrically neutral. Okay, remember electrically neutral, that is the no charges. That means it has the characteristics of it has both positive and negative character combined. Electrically neutral. Electrically neutral. Okay, children. So proton, electron, and neutron, how it arranged in the atoms. Okay, that's we know that atomic structure. This subatomic particle, how it does arrange in a matter or in a atom. Okay, so in the ninth class we studied about the three scientists. We know that J.J. Thomson, his atomic model, we come to understand he said about the plum-pudding model. Plum-pudding model same as the watermelon. The watermelon were the red fibers that are positive charge, and the seeds which are found the black color, that is a negative charge as per the J.J. Thomson. Okay, after his student Ernest Rutherford, when he do the gold foil experiment, in the ninth class we have studied gold foil experiment, he come to understand the SARS, J.J. Thomson's atomic structure theory is wrong. Okay, because the large number of the alpha particles are passed away. That means that he understood about there are hollow space in the atom. Hollow space in the atom, or one or two reflect back, because alpha particles are a positive charge, and from the center to reflect back means we understood positive never join, so it reflect back. So he understood at the center there is a positive charge and more hollow space, and surrounding what revolving? It's surrounding revolving the electrons. Is all noted? So his model also we come to understand same as a planetary atomic model. As all noted, planetary atomic model we said the same as the sun is at the center, the planets are revolving around the sun. As well, the sun is at the center, the planets are revolving around the sun. Same as that model, his model also we come to understand planetary atomic model. Planetary atomic model. Yes. So that is the Ernest Rutherford's theory also such way explained. And after come to understand the Niels Bohr. After Niels Bohr, he said that the electrons has is gain energy. Electrons are gain energy. If it is lose energy, what happened? So according to Ernest Rutherford, if the electrons are continuously move, every moving object when it move in the circular path, what happens? It loses energy. So when it loses, you know that here there is a positive charge, here there is a positive charges. Okay, so if the electrons are revolved, when it lose energy, what happens? It collide with the positive charge. So when negative and positive collide, what happened? The atom will be broke, atom will be blasted. So it is not happening. So that means the Rutherford theory somewhat wrong. Okay, so who proved? The Niels Bohr proved the electrons are revolving in a specific shell. Electrons are revolving in a specific shell, and he known as the K shell, L shell, M shell, N shell, and we come to understand as this structure we derived. So not as per the Niels Bohr structure, we are come to understand the electrons are revolving in a specific path, and each path has a specific number of electrons. We come to understand through the Niels Bohr theory. Okay, so this all we have understood about the 9th class, about the J.J. Thomson atomic structure, Ernest Rutherford atomic structure, and Niels Bohr atomic structure. And if you try to draw the atomic structure of the different, we can make different size or different shape of the atomic structure. For example, I can make this atomic structure as a star model, and I just explained here there is electrons are revolving. This is also one structure. Or I can make as a square, this pattern I can create, and I said that here electrons are revolving and here there is a positive charges. So this is also a structure. So we can make a different structure. Whatever your friends for ask, the friends will make a different structure, your structure will be different. So we can make a lot of structure. Yes or not? So specific structure we are not getting. So it is right. Every element do not have a specific structure of an atom. Every element has a different structure of an atom. So to understand that differences, we first want to know the characteristics of lights. The characteristics of lights. So let's study the first to understand about the atomic structure. Just let us learn the characteristics of the light or the nature of the light. Okay, children, let's start. Now let us start about the characteristics of lights or nature of lights. Already we know the lights and the sounds both are waves. Both are the waves. We come to understand the 9th class also, light waves and as well as sound waves. Okay, so when we take the point of the waves, we just imagine the waves of the ocean water. So how does the waves of the ocean water? Same as this. So not these waves we are come to understand. And already we know that the peak, this is the peak we can call, this is the peak. Okay, this peak we come to understand that is we are saying as a crust. As or not crust, this also we studied in the 9th class. We call it is a crust, and this is just look like a valleys. Okay, this is the peak and this is a valley, and this we called as a trough, T-R-O-U-G-H. This is we called as a trough. Okay, this is the crest and this is the trough. Okay, so remember, listen careful. For just imagine, just I am drawing here one normal line. So we can get now here one crest, one trough, one crest, one trough, and this also we have completed in the 9th class. The difference between, okay, the difference between the two consecutive crests, So this is we called as a wavelength. Okay, this is we called as a wavelength. What we can say, the distance between two consecutive crests or two consecutive trough. So this is the trough or trough we can call, and this also wavelength. Okay, children, so this also a wavelength. Remember, okay, so two consecutive crest or two consecutive trough we can call as a wavelength. Okay, so the which letter we can be denoted by the wavelength, we denote as a, it is a Greek letter, then we are called as a lambda, L-A-M-B-D-A, lambda. How to draw? We are just, why like this keeping, just you make it a reverse. Okay, yes. The while reverse, we will get to the letter lambda. So the letter lambda is denoted for the wavelength. How to draw we understood. So every wave has the wavelength. Another one thing we come to understand, the number of. Okay, so this is as simple as a vibration. Same as when we throw a, just look, there is a pond, water is silent there. When we throw a ball, always when we throw a stone on the water, what will see? You will observe there are some sprinkle, or you can say some circles are forming there. Okay or not? That means we created disturbance in the water. We create a disturbance in the water. So this disturbance created a waves. Okay, same only when we beat drum or tabla, we create a disturbance. So due to this disturbance, they are forming waves, and these waves move forward and backward, forward and backward. Okay, so we come to understand. So every object has if we create any disturbance, they will create a vibration and it occurs the waves. When we talk, if you touch here, you can understand the vibrating. So this, due to this vibration, they create waves, and the waves comes like a sound for our sensitive. Yes or not? So every object, if we create a disturbance, it occurs vibration that create waves. So sound waves and light waves, everyone has the wavelength. Okay, yeah. So when we create a vibration, so we understand, listen, the number of vibration per second. So in 1 second, in how many times it is vibrating, that we call as a frequency. So this also we have completed in the 9th class. Yes or no, children? Frequency, F-R-E-Q-U-E-N-C-Y, frequency. So what do you mean by frequency? The number of vibration per second is called frequency. What do you mean by wavelength? The distance between two consecutive crests or two consecutive trough is called wavelength. Got it, children? So every wave has a wavelength as well as frequency. So just look what the differences we can find from the wavelength and frequency. Okay, children? Let's look. Okay, children, just I am drawing here, once carefully observe. So in this picture we can observe that here I made a vibration is very high. So due to high vibration, what happens? The length or wavelength are small. So here shorter wavelength but higher frequency. Frequency means we know the number of vibration per second is called a frequency. So here more vibration took place in 1 second. So that's the reason the wavelength become less but frequency is more. So here when we come to the large number of vibrations not take place. So that is the reason the wavelength are slowly going. Wavelength are more but frequency are less. So here we understood longer wavelength, shorter frequency. Here shorter wavelength, longer frequency. There was large number of frequency but less wavelength. Understood, children? So we understood both are in opposite. Okay, both are in indirect proportion. When frequency are more, wavelength will be less. When wavelength is more, frequency are less. This one correctly remember. Okay, children? Yes. Now come to our important point. We are seeing the mainly in the rainy season or after the rainfall, we are seeing a beautiful rainbow. Yes or no, children? Beautiful rainbow. So this rainbow, we come to understand there are small class onwards we are studying only the 7 colors are there in the rainbow. That's we know we are called as a VIBGYOR, VIBGYOR. That is VIBGYOR. That means what are they? Violet, indigo, blue, green, yellow, orange, red. So this VIBGYOR also we come to see that is we are called as a visible light. Visible light. So these colors we can see with our naked eyes. So these also one type of light. So it also has a wavelength as well as frequency. Wavelength as well as frequency. So remember this we has a shorter wavelength. Shorter wavelength means frequency will be very high. So I am just making this is our the VIBGYOR because frequency is high, wavelength is small. So when comparing to the indigo, indigo has higher wavelength than violet but lower frequency than violet. Got it, children? Okay, so just I am increase the wavelength. So here come in them somewhat wavelength will increase and here wavelength again will increase. The wavelength are increasing. Can you understand, children? Yes, the wavelength are highly increased. Yes. So here we will get the correct understanding. The red has high wavelength, low frequency. Next, violet has large number of frequency but low wavelength. Okay, very important point to correctly understand. The violet has low wavelength but higher frequency. Higher frequency but wavelength is less. But red has higher wavelength but low frequency. Got it, children? Yes. So when we come to the VIBGYOR, if you say the VIBGYOR, shorter wavelength to higher wavelength. Shorter wavelength to higher wavelength. Got it? Always in the way of the frequency, if you tell, you can understand higher frequency to lower frequency. Okay? So in the term of the frequency, if you tell, you can say higher frequency, VIBGYOR, violet has higher frequency, red has low frequency. In the term of the wavelength, if you say, violet has shorter wavelength and red has higher wavelength. Okay, children, I hope you have understood this one. So this light we are called as a visible light. Okay, visible light. Because with our naked eyes we can see the light. These colors we can see. Got it, children? Okay, so we come to understand, to study about these light or these waves. We are using the term only we called as a spectrum. Remember, spectrum. Okay, so you may be here, you may be so also like this spectrum. Okay, when white light is appeared in the spectrum, it split into 7 colors, different colors, mainly VIBGYOR. This is we called also dispersion of light. Remember, more about these topics about the light, much about you will study in the lesson Humans Eye and Colorful World. Okay, yes, so we understood about the spectrum as well as visible light. Okay, so let us come to understand about that. When electrical charge, because we know electron, proton, neutron, they are electrically neutral. Yes or no? It's a positive charge and negative charge and electrically neutral neutron. Okay, so remember, when a vibrating electric charge create changes in the electrical field. Okay, so electrical charge if get vibrated, it creates changes in the electrical field. We know whatever things, every matter is made up of atoms, and atom has subatomic particle. So in our surrounding, whatever we see, they are all electrical charges are the electrical charges. So when electrical charge get vibrate, it creates changes in the electrical field, and when electrical field get changes, it creates changes in the magnetic field. So this topic very important. So when electrical charge get vibrate or vibrating electrical charge create changes in the electrical field, and the electrical field changes creates changes in the magnetic field. Yes or no? So these both are interrelated and perpendicular to each other. You can see here this graph, this movement of the electric field. You can understand the both get changes, but both are in the perpendicular direction. This is we called electromagnetic waves. Electromagnetic waves or electromagnetic field. Okay, understood, children? So the electromagnetic wave has wide variety of frequency, from shorter frequency to longer frequency. So the entire range of electromagnetic wave frequency is known as electromagnetic spectrum. Remember, electromagnetic spectrum. Okay, electromagnetic spectrum. Okay, listen careful, children. So what I am said about electromagnetic wave has wide variety of frequency, from shorter frequency to longer frequency, or shorter frequency to higher frequency. Okay, so the entire frequency from shorter frequency to larger or higher frequency of electromagnetic wave frequency is known as electromagnetic spectrum. And also we know when there is a frequency, of course there is a wavelength also. Okay, so we can understand electromagnetic wave have wide variety of wavelength, same from shorter wavelength to longer wavelength. So the entire range of electromagnetic wavelength is known as electromagnetic spectrum. So both the way we can say what we mean by electromagnetic spectrum. Okay, together you mix and also we can say that means electromagnetic wave have wide varieties of frequency as well as wavelength. So the entire range of frequency and wavelength of electromagnetic wave is called electromagnetic spectrum. So with the division also you can say, or together also you can tell in your textbook clearly it mentioned. So that is the electromagnetic spectrum. So now let us understand what is this the shorter wavelength to longer wavelength or shorter energy, shorter frequency to higher energy. Okay children, let's go. Okay children, so here is the electromagnetic spectrum from the shorter wavelength to higher wavelength or higher frequency to lower frequency. Okay, so we can let us start from the gamma rays. Here I just mentioned as the first one cosmic rays. It is a very shorter wavelength and higher frequency. Is not taking this term and we are going with the gamma rays. We are starting with the gamma rays. Okay, so here is the gamma rays has the higher frequency but lower wavelength, shorter wavelength. Okay, and next come to the X-rays, after which one UV, ultraviolet rays. Ultraviolet rays and infrared rays, these two between we have the visible light. So this is we call as a visible spectrum. Visible spectrum, that is a VIBGYOR. Already we understood the violet has a higher frequency but a shorter wavelength. Okay, so the wavelength are increasing here. Wavelength are highly increasing. So comparing to the infrared rays and ultraviolet ray, who has higher wavelength? Yes, of course, infrared has higher wavelength and who has a shorter frequency? Yes, the infrared has a shorter frequency because higher wavelength, shorter frequency. This is shorter wavelength, higher frequency. After we come to the microwaves, that means we are using the micro oven. Micro oven, do you know? Yes. So to heat, example, pizza, burger, we are eating purpose in bakery also we are seeing microwave. They are going the waves, microwaves. It has a higher wavelength. So remember, when the wavelength are increase, its intensity will be increased. Okay, so that's the reason VIBGYOR we can easily visible the color is red because higher wavelength the intensity or brightness will be very high. Brightness will be very high, and microwaves than higher wavelength, that is radio waves. That is the reason in Hyderabad how the radio station we can be tuned in our Medpalin also because the radio waves has higher wavelength, so it will travel very long distance. So next one, broadcast television program, this also has a higher wavelength. That's the reason the faraway country have the live telecast also we can see in our room. Is all noted? So this is the entire range of the electromagnetic spectrum from the gamma rays to radio waves. Gamma rays to radio waves.
Something surrounds you, bombards you, some of which you can't see, touch, or even feel. Every day, everywhere you go. It is odorless and tasteless, yet you use it and depend on it every hour of every day. Without it, the world you know could not exist. What is it? Electromagnetic radiation. These waves spread across a spectrum from very short gamma rays to X-rays, ultraviolet rays, visible light waves, even longer infrared waves, microwaves, to radio waves which can measure longer than a mountain range. This spectrum is the foundation of the information age and of our modern world. Your radio, remote control, text message, television, microwave oven, even a doctor's X-ray, all depend on waves within the electromagnetic spectrum. Electromagnetic waves, or EM waves, are similar to ocean waves in that both are energy waves. They transmit energy. EM waves are produced by the vibration of charged particles and have electrical and magnetic properties. But unlike ocean waves that require water, EM waves travel through the vacuum of space at the constant speed of light. EM waves have crests and troughs like ocean waves. The distance between crests is the wavelength. While some EM wavelengths are very long and are measured in meters, many are tiny and are measured in billionths of a meter, nanometers. The number of these crests that pass a given point within 1 second is described as the frequency of the wave. One wave, or cycle, per second is called a hertz. Long EM waves, such as radio waves, have the lowest frequency and carry less energy. Adding energy increases the frequency of the wave and makes the wavelength shorter. Gamma rays are the shortest, highest energy waves in the spectrum. So, as you sit watching TV, not only are there visible light waves from the TV striking your eyes, but also radio waves transmitting from a nearby station, and microwaves carrying cell phone calls and text messages, and waves from your neighbor's Wi-Fi, and GPS units in the cars driving by. There is a chaos of waves from all across the spectrum passing through your room right now. With all these waves around you, how can you possibly watch your TV show? Similar to tuning a radio to a specific radio station, our eyes are tuned to a specific region of the EM spectrum and can detect energy with wavelengths from 400 to 700 nanometers, the visible light region of the spectrum. Objects appear to have color because EM waves interact with their molecules. Some wavelengths in the visible spectrum are reflected and other wavelengths are absorbed. This leaf looks green because EM waves interact with the chlorophyll molecules. Waves between 492 and 577 nanometers in length are reflected, and our eye interprets this as the leaf being green.
When a ray of light falls on the prism, a sequence of colors are produced, which is called as visible spectrum.
Okay children, so I hope you understood about today's topics and more about the electromagnetic spectrum and the atomic structure, how changes happen, how the model of the atomic structure we can make. So that all we will study in the next class. Okay children, and I hope you understood well about this topic. If you have any doubt, you can ask me, I will help you. Okay, so thank you so much for watching. Take care.